just like how it sounded.
All right, here we go. Here's what I did for you guys first, nice and easy. All right, so you don't have to do it yet. What I did was I did all my shading. All right, I graphed and shaded a bunch. Then this is where my shaded region ended up, right here. All right, there's not an S there. I don't need to put one, but just pretend like that's where all my shaded regions overlap, right there. This figure, all right, this figure. And what we're going to start doing now is we're going to take the corners of our figure, all right, the vertices of the figure, and plug them into what's called an objective function. This is going to be something new for us. That will always be given to you today. Wednesday, different story. But for today, I'll give you an objective function. That will tell us what gives us the maximum value and also the minimum value, which we're going to be, that's what we need when we start the word problems later on in the week. So what we're going to do, we're going to shade, which I already did for you. We're going to take the points, the vertices of that shaded region, and plug them into the objective function and see which one gives us a maximum and what's the minimum value. And plugging them in is very easy, very easy. So let's take give me one of the points you want to start off with on the figure. 410. All right, so we take 410. The 4 is the what coordinate? The x, and the 10 is your? So we plug them in. So I take my objective function, z equals 3. What are we going to plug in now? Times 4 plus 2 times 10. And we'll see what that z value ends up giving us. I want to find the pair that gives us the maximum and the minimum according to the directions. So what do we got here? 32? All right, 32. Keep going, because it looks like I have 5 points total. What do you want to plug in next? I got 410. What else you want to plug in here? We got to plug them all in. 8, 6 it is. Z equals 3 times 8 plus 2 times 6. We're looking at 24 and 12, 36. All right, I don't need to hold your hand anymore. You guys can go ahead and check the other 3.
Okay, so I have to have this. What was that? What was that? Got my hair back. Oh, man, this was I thought it was still And they do that for me on like door. Because it's wrong. Yeah, that would be I think that's what my hand has.
Look good? I got 39, 29, and 13 for the other 3. Look good? All right, so let's answer the question now. What's the max value of this objective function? The max value, 39. And the minimum value should be 13. And I just want you finding it today. We're actually going to put like real, quote unquote, real life examples to this on Wednesday when we would use this. All right, but 39 and 13. Any questions? All right, so here's your big job for today. You're going to come up with that region now and the corners. All right, I'm not going to do it for you. You're going to do it. How? I'm going to give you the inequalities of the graph. All right, I'll give you the inequalities of the graph. You guys find that shaded region. You got to use a straight edge. So important to use a straight edge because I need to see where these vertices are. We need to see what they are in enable. Okay, so let's go through a couple together here before I let you go on your own. Keep it to the first quadrant again, because when we start the word problems, it's always going to be positive answers, never negative. So keep it to the first quadrant for me. You have your numworks calculator, which you can certainly type it in. You guys remember where the greater than or equal to? Do we need a refresher? Toolbox is the greater than or equal to. If you're just looking for the plain less than or equal to, that is with the radical and the x squared button. So you ready? X is greater than or equal to 0. That's another name for what? X is greater than or equal to 0. What's that line look like? Shouldn't be diagonal.
Oh.
Remember, hey, look, I got 1, 2, 3. I got to go graph 4 of these and shade. So if you go to your graphing calculator, X is greater than or equal to 0. What's it look like? It's the what axis? Should I go there too, I guess? X is greater than or equal to 0. Plot the graph. It's the y-axis, isn't it? Okay. Just a little piece of advice: probably would not shade everything here. You don't need to, right? We know because what are you going to end up shading? The whole darn thing. That's not going to tell us much. All right, so don't shade the whole. I wouldn't. You can if you want. If you got 4 distinct colors, sure. So this is X is greater than or equal to 0. I probably wouldn't shade the whole thing, but if you want, go ahead. You ready for the next one? Y greater than or equal to 0.
Same thing, but on the x side.
There you go, right here. Not shading, because you guys would shade this whole darn thing here. All right, not doing that. All right, now let's get real now with the shading. 2x plus y is less than or equal to 8. I know it's been 10 days together since we did this, so let's do it all together. Let's go back and type in that one. Two x plus y less than or equal to 8.
So that wasn't.
Okay, just a review on this. What it's showing me right now is your x-intercept, right? X-intercept is 4, 0. X-intercept 4, 0. Y-intercept. Let's review this. It's fine here because you guys can probably just scroll up to it, but sometimes, we got huge numbers, in the tens of thousands and maybe millions, and sometimes scrolling isn't the best choice. So remember how to get there immediately. Go up to calculate, and you want to know when the x value is 0. So you type in 0, you hit enter. So again, I went up to calculate, x when x is 0, enter, and it'll go right to your y-intercept, which looks like 8 to me, 0, 8. Please find those intercepts before you graph anything, because you want to know, maybe I got to change the here I don't, because we can go by ones, but sometimes, if it was 22 or 25, I'd have to change my interval. All right, everyone ready? 1, 2, 3, 4, 0. 1, 2, 3, 4, 5, 6, 7, 8. Looks like all these are solid lines. Again, straight edge. We got to know where these corners are. Straight edge. And where's the shading going? Where'd my calculator go? Looks like we're shading down to the left. And you're ready for the last one. Go ahead, you guys can go ahead. Find your intercepts for that last one. Six zero zero four.
That's my favorite one. It's the one you took from me. No, it's not. Yes, it is. Yeah.
And where's the shading? To the left or the right? So you see where they're going to overlap. You see where our solution will be. Right here. Okay, that's where we were before break. Now we got to take it to the pre-calc level now. Everyone sees the figure that it forms. It forms a four-sided figure for me right there. The shaded region forms a four-sided figure. I need to know all 4 points. Exact points. Not like, oh, it looks like this or no. So let's go around here because this is going to be part B now, which is determine the objective function at each of these, which is what we did in the first problem. So anybody have a clear point that you're confident in? 4, 0. Okay, 4, 0 it is. So I take 4, 0. And I plug it into the objective function they gave me. Z equals 2 times 4 plus 3 times 0. Bless you. So 8, Z equals 8. All right, there's 1 of 4. Another point you're confident in if you use the straight edge. 0, 4. I like that one. 0, 4. Two times 0 plus 3 times 4. So it looks like I get a Z value of 12. All right, 2 more points. Another one you definitely should be confident in.
0, 0.
0, 0, right at the corner, right? That could be, it's going to be 0. All right, now I got to show you the trick because this is the most controversial, toughest point is where the 2 lines intersect each other. All right, and I'm talking about on this one right here. Okay, first, what do you think? Before I show you how to check if you're right or not.
3-2.
You think it's 3-2? Yeah. Anybody think something different? Maybe on yours? it's closer to another point, or maybe it doesn't land exactly on it.
Oh, it's gonna be 3.52.
It won't be I will never give you decimals. I promise you that. It'll never be a decimal. It'll always be whole numbers. So do we think 3.2? Okay. So to check, these 3 points that we just did are we're pretty solid on those. Is it 3.2? Well, maybe it might be 2.2. All right. It might be 2.3 instead. How do I check? You plug it back in to either inequality right now. So 3.2. Ready? If I plug 3 in here, what do I get? 6 plus 2, which is your y, what do you get? 8, which is the number you should get over there. If I do it over here, ready? 2 times 3, 6. 3 times 2, 12. So you plug it into either line, it should give you the number that's on the other side. That's how you can check. Does that make sense or no? So 2.3 is the point, correct. So you plug whatever point you think it is into either inequality for the line. Go ahead, Kate. Thank you. That kid. Everything else good up here? We're good? Yep, everyone's a jokester. All right, now here we go. Don't get rattled. Don't get rattled. Plugging that into that one. So 2 times 3 plus 3 times 2. And that's 12. All right, part C. Whoa. We got 3 parts here. Determine the max value and the values for which they occur. So what is the max value first? 12. All right, so max equals 12. But now I'm adding a different piece to it. When does it equal 12? Well, when x give me one instance where it equals 12. When x equals? When x equals 3 and y equals 2. And there's another instance, isn't there? This is a rare one. We get 2 max values. And also, where can I get a max of 12? And when x equals 0 and y equals 4. And I know, just trust me for now. I'm going to actually, like for instance, I'm not even going to go into it. I'm going to wait until Wednesday. I just want you guys to find the max for now. Question?
Why didn't I have more equations?
No, but I'm just looking for the max. What gives me the maximum value? Like here, the number was 8, but I can get 12 from here, which is higher. I'm looking for what gives me the maximum z value.
Okay, but what about like 0, 8? Like what about that?
But that wasn't in my solution though.
Oh.
I only want points that are in my solution page. Okay, good question. Yes, Max.
Do we still have to label the lines?
I'm not going to be picky about that. There's so much to do now. I'm not going to. That's the last thing I'll worry about. Okay. Anything else? All right. One doesn't make you great. One more to get out of here. While we're setting this up, anybody big plans later for the viewings? Anybody big plans? Going to behave? Oh, that sounds like a blast. Yeah. Yeah. No big plans for viewing. Hopefully we'll be behaving. If we do go to a viewing party. All right, sorry I brought it up. First one. First one. You can't type this into the calculator. You either remember what this looks like because it's X only, or you break it up and type each into the calculator. 1 is less than X. X is less than or equal to 5, but I think you guys are good enough. What type of lines are those going to be? X only. Vertical lines going through 1 and 5, correct. But if you forget, just type them in separately. So we got a vertical line going through 1. Shoot. And a vertical line going through 5. 2, 3, 4, 5. Where's the shading going to be? Where's the X? In between. So if you want to go ahead, shade in between if you want. I'm going to save my shading to the end, but you can shade in between if you got distinct colors here. Y is greater than or equal to 2. Graph it on the calculator. Or remember, what type of line is this one? Horizontal going through 2. Use a straight edge even for horizontal and vertical lines.
NGO.
What? Oh, wait. Yeah, this one's at. Wait. Oh, it's positive.
Oh. There's no dots.
All right, something's going to happen here when we graph x minus y is less than or equal to -3. I don't need anybody to freak out. All right, I'll graph it with you. Let's go. Let's go to the calc. Let's graph this beast. Greater than or equal to 3. Okay, everyone ready? I press graph. It'll get me to, what's it getting me to here? My Exeter? It's giving me 4, 7, huh? Yeah. Or did anybody get a different one? Yeah, okay. So -3, 0. That's my x-intercept. But where do I ask you guys to graph? First quadrant, right? So there's no way I'm graphing that. All right, so you can't graph this. Thank you, Grant. Pick another point. You can get the y-intercept. That's no big deal. Take a look. 0, 3. We can graph that. So we can graph the y-intercept. 0, 3. It's just because we're sticking to the first quadrant, hey, that x-intercept's not going to cut it. So keep going and find another point that will cut it.
4, 7.
I don't like those. 2, 5. 4, 7. Whatever floats your boat. Okay? So 2, 5 or 4, 7 can work. Because again, you can't graph the x-intercept. We're sticking to the first quadrant. Use a straight edge. 0, 3. 1, 2, 3.
Okay.
And 2, 5.
Oh, that's fine. And the y is greater than or equal to.
And then let's see if we find our solution set here.
Wait, it's greater. So it has to
Where is it? Can you find the figure that makes your solution set? Can you find it? Maybe all your colors are blending right now. Can you figure out where you, I don't need to see it, but where would you put that big S for solution set here? Little triangle. This is not a triangle to me. Triangles have 3 sides. This has 4 where I think it's going to intersect. Oh, can he do it? Can he do it?
I didn't see that.
I thought I was going to be able to just fill it in. Oh, here you go. Right here.
I thought it wasn't good, but it's like a little
Quadrilateral. It's got 4 sides. Okay, you want to throw a trapezoid? Maybe throw out something different? Yeah. Throw out a trapezoid.
It's a sharp thing.
All right, we ready?
Now we plug it in.
Yeah.
Now we go pre-calc here. Find all 4 points for me. Find all 4 points. Anybody confident?
1, 2.
1, 2. Definitely 1, 2. That's where the vertical and the horizontal line. Nice job. 1, 2 it is. Okay, so I'll do 1, 2 first. Plug that in for Z. Make sure you get out -1. Anybody else confident in another one? Probably where those horizontal and the easier ones are probably where the horizontal and vertical lines meet. But 5, 2. We got a winner. 5, 2 right here. Yep. What do I get with 5, 2? Z equals 11. Maybe?
I can't really see mine.
Oh, I don't know. Could it be 5, 8?
It is.
Are you saying this point right up here, Grant?
Yeah.
Possible answer 5, 8. How can we check? Go back to the inequality of that diagonal line. Ready? Plug in 5 and -8. What are you going to get? 5 minus 8, -3. We got a winner. All right, it fits into that diagonal line. So 5, 8. And what's that going to give me? -1 again. All right, how about that final point? Make sure it fits into here. When I do the x minus the y, I should get -3 when you tell me that point. 1. Yeah, 1, 4. 1 minus 4 gets me. So z equals 1, 4. I got -5. All right, so we did all that. And unlike the last problem, this is what most of the problems will be like. There will only be one max. My max value for this region is 11. When do I reach the maximum value? When x equals 5 and my y equals 2. Didn't ask me for minimum, so that's all I'm doing.
Do you have to do the inequalities? Where did it ask you for?
What do you mean, label your lines?
No, for like the inequalities of like.
What do you mean? I will give them to you tomorrow, but then Wednesday you have to make them up based on the word problems we do. That's where we're going towards. Finish this unit. Yep.
Did you guys watch that movie?
Yeah.